to continue on. We're going to continue on with chapter 6. Yesterday we did some work with monomials. Today we're going to move on to polynomials. The first thing that we're going to look at is to determine whether something is a polynomial and one variable or not. So this first example says determine whether c to the fourth minus 4 square root of c plus 18 is a polynomial. If it is a polynomial, state the degree. Well, in order for it to be a polynomial, it must first be a monomial. There are some things that kind of make it not a monomial. In this first example, one of those things is that it has the square root of c. If our variable is underneath a square root, like in this example, it's not a monomial. And if it's not a monomial, this expression cannot be a polynomial. Okay. So we would say that this expression, here's our answer, this expression is not a polynomial because the square root of c is not a monomial. Do you guys have some notes you can get out? That we need to look for is if we have a variable underneath a square root, if we have the variable in the denominator of a fraction, or if our variable has a negative exponent. If any of those things occur, then it's probably not going to be a polynomial. Okay? If any of these things occur, then it's probably not going to be a monomial, which means that it's not a polynomial. In this example, it says determine whether negative 16 p to the 5th power plus 3/4 p squared q to the 7th is a polynomial. If it is a polynomial, state the degree. Well, do any of those three things occur? Do you have a variable in the denominator? No. Do we have a variable underneath the square root? Do we have a negative exponent? We don't. So it is, each term is a monomial. So this is a polynomial. You would say that yes, it is. They also ask us to find the degree. In order to find the degree of a polynomial, we look at each individual monomial. So the degree of this monomial, we would say, is 5. The degree of the second monomial is 9. How am I getting those numbers? 5 and 8.
Exponents.
Right, I'm adding the exponents. So the first monomial has a degree of 5. We'll have one exponent. Here in the second term, I have 2 plus 7, that gave me 9. So we would say the degree of this polynomial is 9. We take the highest degree. Example C, determine whether x squared minus 3x to the negative 1 plus 7 is a polynomial. If it is a polynomial, state the degree. Is it a polynomial? No. What part makes it not a monomial? The negative exponent. We have a negative exponent here in this middle term, so this is not a polynomial. So here in this example, I would like for you to state, they're asking, is it a polynomial? If it is, state the degree. Good. Letter A is the correct answer. Yes, it is. A polynomial has a degree of 5. How about this one? D is the correct answer. It is not a polynomial. What makes it not a polynomial? The square root of c.
Why it's not a polynomial?
If it asks you to, yeah. We'll just follow the directions if they do ask us to. How about this one? Okay, on this one, first of all, is it a polynomial?
Yeah.
Absolutely, yes it is. It doesn't have any of those things we talked about. It doesn't have a variable into the square root. Doesn't have a variable in the denominator. Doesn't have a negative exponent. So yes it is. I know D is not going to be the right answer. Degree. What is the degree of the first term? That's 3. What is the degree of the second term? Not 6. It's 7. How did I get 7? G has an exponent of 1, so 1 plus 6 is 7. And then the last term has a degree of 1. We picked the highest, and the highest is 7. C would be the correct choice. So whenever you're looking for degree, you look for the highest exponent. And don't forget about those variables that have exponents of 1. Okay, these next few problems, we're going to do some simplifying. We did some simplifying with imaginary or complex numbers. This time we're going to do the same thing with polynomials. What operation are we doing between parentheses? Subtracting. So we need to distribute a -1. I'm going to bring down the first parenthesis. And now distribute your -1. -1 times a cubed. Negative a cubed. -1 times -3a. Positive 3a. -1 times 2. -2. Now at this point we need to add and subtract like terms. Back in Algebra 1 when you talked about like terms, what makes something have like terms? Same variable and exponent. They have to have the same variable and exponent. When I do this, I like to underline. So for example, I'm looking for other a cubes. Well, I have another one right here, -1 a cubed. So I'm going to take 2 minus 1, which is 1 a cubed or a cubed. And then when I'm looking for the next term, I'm going to underline it twice. You can identify however you want, but I feel it makes it a little bit easier to underline or circle or square in as you find your like terms. We also have 3a that we can combine with 5a. 5a plus 3a is 8a. Add those coefficients. For constants, I have -7 minus 2. -7 minus 2. -9. Can I add any of these terms together? No, they all have different exponents. They have the same variable, but different exponents. So we need minus. That is my final answer. Guys, remember, you can multiply anything you want. You can multiply anything you want. You just cannot add and subtract unless they're like terms. How about this example? 4x squared minus 9x plus 3 plus -2x squared minus 5x minus 6. Do we have, or what operation, first of all, are we doing? Addition. That plus sign between the two parentheses tells us what we're doing. Should I distribute anything? No, just add and subtract. This is where some of you went wrong on your test from last chapter. You were wanting to distribute. Just combine those like terms. There's nothing to distribute, so I'm just going to add them. 4x squared minus 2x squared is 2x. -9x minus 5x minus 14x. Positive 3 minus 6. 3 minus 6 is -3. Can I combine any of those terms together? No, they all have different exponents, so I cannot combine them. This one is a multiple choice problem I would like for you to do on your clicker. You go ahead and simplify. So I'm going to bring down the first expression. -1 times 4x squared negative 1 times x is x. Negative 1 times negative 5, positive 5. So add those like terms. 3x squared minus 4x squared is negative x squared. 2x minus x, positive 1x. Negative 3 plus 5, positive 2. Letter D is the correct answer. So if you didn't select D as your answer, make sure you do fix your notes. About this one, here we have another multiple choice question. Go ahead and simplify, please. We all agree that it is B. Let's go ahead and distribute our negative 1. Nothing happened to the first expression, so I'll bring that down. Now I'm distributing my negative 1 through the second parenthesis. And then combine those like terms. Negative 3x squared and negative 4x squared is negative 7x squared. Negative 4x and negative x is negative 5x. 1 plus 5 is 6. B is the correct answer. All right, any questions on adding and subtracting, like terms? Okay, the next thing we're going to do is work with some multiplication. In this problem, they're asking us to use a distributive property. How many times are we going to have to distribute? Twice. We have to distribute twice. Before we work this problem, I want to remind you, if you take a variable times a variable, x times x, what do you do to the exponents? Add them. You add the exponents, so it would be x squared. Oops. So in this case, when I'm distributing, I've got to think about that as I distribute. So negative 2x, I'm taking negative 2x times everything in the first parenthesis. Negative 2xy, times 4y. Negative 2xy times 4y. Negative 2 times 4 is negative 8. X, y to what power? The second. Take negative 2xy times positive 2xy. Negative 2 times 2 is negative 4. X times x is x squared. Y to the second. Negative 2xy times negative 3. Well, negative 2 times negative 3 is positive 6xy. And the next parenthesis, I'll distribute my negative 3y. I'm out of room here on the top line, so I'll have to make it go down to the second line. Negative 3y times xy is negative 3xy squared. Negative 3y times 4x squared y. Negative 3 times 4 is negative 12x squared y squared. Did you notice every time I put these letters, these variables, in alphabetical order? I do want you to do that. We don't say y squared x squared, we always say x squared y squared, so please put in alphabetical order. I'm not quite finished. There's something else I can do. What else can I do? Combine like terms. Now, when we add and subtract like terms, do we do anything to the exponent? No. When do we adjust the exponent? When do we add the exponents?
Multiplication.
Or multiplying. Right now, we're just adding and subtracting like terms, so we don't do anything to the exponents. So we have negative 8xy squared. That can be combined with negative 3xy squared, which is negative 11xy squared. Again, I'm just adding and subtracting the coefficients. Nothing happens to the exponents. So to my next term, I have negative 4x squared y squared. I can combine that with negative 12x squared y squared, which is negative 16x squared y squared. Is there anything to add to 6xy? There's not, so we'll just bring it down.
Is there a certain order there that they have to be in?
Technically yes, but we're not going to worry about that in algebra 2. I'll take it in any order it comes in. I want you guys to try this one. Multiple choice question where you're distributing the negative x. Mostly C's. Let's go ahead and work this one. So to distribute our negative x. Negative x times 3x cubed is negative 3x to the 4th. Negative x times negative 2x is a positive 2x squared. Negative x times 5 is negative 5x, which would be letter C. Now this next problem is a little bit different. We have a trinomial, 3 terms, times a binomial, 2 terms. Any thoughts how you would simplify this?
Distribute your two C's together.
Distribute, that's exactly right. We're just going to distribute. We have 3 things to distribute in the first parenthesis. We're going to take each of these values in the first parenthesis times everything in the second parenthesis. So let's start by multiplying a squared times a. Into the third. A squared times 2. 2 a squared. The next thing we'll distribute is our 3a. 3a times a. 3a squared. 3a times 2. 6a. And the last thing we'll distribute is our negative 4. Negative 4 times a, negative 4a. And negative 4 times 2, negative 8. Am I finished? We can combine like terms. Remember, you're adding and subtracting. Do you do anything to the exponents? No, you only add the exponents if you're multiplying. Is there anything I can combine a cubed with? No, there is not. So I'll just break down a cubed. I have 2a squared. I can combine that with 3a squared. Is 5a squared. We don't do anything to the exponents. Go to my linear term. 6a minus 4a. 6 minus 4 is 2. Positive 2a minus 8. Again, none of the others are like terms, so I can't add any of those values together. What if I have a binomial times a binomial times a binomial? Distribute all 3. Now, you can only distribute 2 parentheses at a time. So before I jump into this, I'm only going to worry about the first 2 parentheses. I'm not even going to worry about the last one for the time being. I'll catch it up in just a second. Do you notice anything about the first 2 parentheses, Logan?
They're like reciprocals, basically.
Not reciprocals, they're conjugates. They are conjugates. Do you remember our shortcut for multiplying 2 conjugates? First and last. Now, if they weren't conjugates, we'd have to distribute all the way through, correct? They just happen to be conjugates, so you can use that shortcut.
Well, after you multiply those 2 parentheses, can you just take your answer from that and then multiply times the next parentheses?
Exactly. So I'm going to use my shortcut because the first 2 parentheses are conjugates of each other. So a times a is a squared, and b times negative b. Again, they just happen to be conjugates. Now I need to take that answer times 2a plus b. Now are these 2 conjugates?
No.
No, so I'm going to have to do the long way. I'm going to have to distribute all the way through. So a squared times 2a, 2a to the 3rd power. A squared times b.
A squared plus a squared b.
Plus a squared b. Next we can distribute our negative b squared. Negative b squared times 2. It's negative 2ab squared. And please put those in alphabetical order. Negative b squared times b. Negative b to the 3rd. Do we have any like terms that we can combine? No. This is our answer. We have 4 terms are our answer. I want you guys to try one. This will probably be our last example. Our last practice problem, I should say. Good. Most all of you that sent in an answer said A is the correct one. Let's just go ahead and simplify here. X squared times x is x to the 3rd. X squared times 4. 4x squared. We'll distribute our 3x next. 3x times x is 3x squared. And 3x times 4, 12x. Distribute our -2. -2 times x is -2x. -2 times 4 is -8. We can combine like terms. I think we have some x squareds here. 7x squared. Linear terms, 12x minus 2x is 10x minus 8. A is the correct answer. Okay, we are going to take a quiz over section 6.1 on Friday in here. 6.1 on Friday we'll take a quiz over section 6.1. That is the simplifying the monomials. That's what we did yesterday and Friday. What we're doing today, we'll do some more of this and kind of some review tomorrow. We're going to do our quiz on Friday. And after our quiz, I do plan to go ahead and move on. So kind of be looking for that. Give me just a second. I just want to verify that this is the correct assignment real quick. Make sure I have the right